Hi, everyone. This lecture is on processors and memory. We're going to talk about microprocessors, how processors work, some information regarding performance. We'll talk about memory as well, random access memory, RAM, and read-only memory. Microprocessors. We already talked a little bit about microprocessors, the microchip as the integrated circuit and the brain of the computer. Intel's 8086 family of microprocessors powered the original IBM PC in the late 1970s, which was one of the first personal computers with 16 bits, kind of amazing. So in 1970s, the microprocessor was operating on 16 bits. That's not even, that's 2 bytes, 2 bytes. It's kind of crazy, no? A bit is 1 byte is 8 bits. The 8086 chip family set the standard for processors used today. So it's something about the architecture kind of set the standard. We're not going to go deep into this, but we just mentioned some things that are sort of broad and useful to know about the microprocessors. The standard is sometimes referred as x86. So if you see x86, that means the kind of modern, often used standard for chip architecture. Processors found in today's desktop and laptops are usually x86 compatible. So there are 2 types of microchip architecture that are as important to note, and really 2 main defining characteristics. One is complex instruction set computing, or CISC, and it was the original instruction set architecture of microchips, and it was actually kind of retroactively named once the following one came, because they didn't even have a difference. It was just kind of all the same. And in this model, there's a single instruction set that can execute several types of operations. So it's a complex instruction set, since the instruction set, instruction for the operations, the manipulation of the zeros and ones this one is very flexible, and you can do things, load from memories, compute some number, store some other values, and so on. So the original was CISC, and now there is a one called RISC, reduced instruction set computing. And this created regular instruction pipeline with defined operations. So you can't just put everything in the instruction set. It has to be very specific, and it's limited and it's regular. This reduces clock cycles per instructions, so it's faster, and employs a more strict load and store instructions, employs strictly separate load and store instructions. So it's more defined, it reduces the instruction, and it's also it reduces the clock cycles or the cycles of operations, and therefore the energy and the resources that it needs. Processors based on ARM technology dominate tablet computers and smartphones. So these are a kind of RISC. And when you see RM, and if you notice some of the chips in the pictures here, you see that they are ARM, which is a kind of RISC machines, and they're mostly now on tablet computers and smartphones. That's the kind of chip they use. They're energy efficient, once again, because of that specialized instruction set, and hence their prevalence in battery-powered devices. You can find them in iPads, iPhones, Galaxy phones, and others. How microprocessors work. We are really not going to get deep into how microprocessors work here. So I'm just very broadly mentioning some things. Microprocessors cannot directly communicate or understand, interpret the programming languages such as C++, BASIC, COBOL, and Java, which you may have seen. Something, which looks kind of like English, like something like print, hello world, hello, or just say hello. This is an instruction from a program like Java or Python. You literally write it in English and you write it in text. However, for the computer to understand, it has to translate these all to binary. It has to be translated to machine language that correspond to how the microprocessor understands the instruction. And ultimately, once again, always goes back to the zeros and ones. But the microprocessor may have etched in it that, for example, when it sees 0, 0, 0, 0, 0, 0, 0, 0, this 1 byte of just zeros, it does is add. If it sees this kind of binary data, it will do an input operation. If it sees this binary data, it would do a multiplication and so on. The term instruction cycle refers to the process in which a computer executes a single instruction. So often an instruction itself may have various operations. So when you hit the on and off button, some things will kind of need to execute on the computer, and the instruction cycle is that cycle of that particular instruction set. Operational units of the microprocessor. So the microprocessor, the integrated circuit, that little chip that we've been talking about, it's fairly complex. We're not going to go into the details. It's much more than this. It's a highly abstract and focused view of the microprocessor. So it's just to first have some notion of how it works. There's usually a control unit, and there's usually also a arithmetic logic unit. The arithmetic logic unit is part of the microprocessor that performs arithmetic operations, such as addition and subtraction, and all the other more complex ones as well. The control unit fetches the instructions of what to do and other kinds of instructions of how to manipulate the arithmetic, and then submits it to it. So there's a separate unit to actually control the operation, some units to do the mathematical logic itself. Performance. A microprocessor's performance is affected by several factors, including clock speed, number of cores within the microprocessor that actually processes the data, processing techniques, cache size, and instruction set. There are quite a few. A processor specification, such as 3.4 gigahertz, you may have kind of see these numbers on the processor, and that has to do with the speed of the microprocessor clock. So essentially, how fast is the execution of the instructions? So usually the higher, the faster it can execute instructions. And when you can see the hertz is cycles per minute per unit. So this refers to a time measurement of the speed of the processor. A cycle is the smallest unit of time in a microprocessor universe. Every action a processor performs is measured by cycles or hertz. Gigahertz means 1 billion cycles per second. So 3.4 gigahertz means it can process 1 billion cycles per second. It's crazy. It's really crazy, but it really does do that. A microprocessor that contains a circuit for more than one processing unit is called a multi-core processor. And many of the processors now in your regular laptops, so when you see something like the Intel Core i5, it has multiple cores inside the chip itself to do the control and to do the arithmetic logic, to do that processing of the data as needed. Memory. Memory is where binary data is stored in a microprocessor or larger circuit board. So within the CPU, the microprocessor, the microchip, as we mentioned before, we're kind of going to see the control unit that actually handles what action is set to what. There's the processing itself of the data. And then there's the memory. And there might be some memory inside the CPU itself, but the memory is a kind of often considered its own storage place, its own storage device. And it receives instructions and it sends instructions as well. So there are two types of memory. There's primary memory, which is the ROM, read-only memory, and that's stored in your computer, and it can only be read and non-modified, and random access memory, which is the memory that usually the microprocessor needs to do its computation. Every time something's computed, sometimes you have to store something in the memory while it's doing its computation and kind of go back to it. This is random access memory, is volatile though, and it's constantly moving. Secondary memory includes the hardware storage devices like hard disk drives, solid state drives, and other devices, flash drive, and so on, which we talk about. Read-only memory. Read-only memory is a type of memory that is housed in a single integrated circuit on the system board. So that is a kind of memory that you cannot modify, it's only read, and it carries out the instructions to, for example, load the operating system. So when you hit the power button on your computer, it sends an instruction to read the read-only memory, which has information on how the computer should even turn on to begin with, and even to check for an operating system to do something. So that's the read-only memory. It's kind of the bootloader. That means it's the loader to start the booting or the start of the computer. ROM contains a small set of instructions and data called the bootloader that tell the digital device how to start. Random access memory. Random access memory is a temporary holding area for data while instructions are being processed. Higher RAM capacity adds to the expense of a device, the cost, but also its processing speed. Most RAM is volatile, meaning needs electrical power to hold data. So RAM does not provide long-term storage. Things are always changing and moving around in RAM. If a computer shuts off or crashes, data in RAM is lost. Of course, for example, I'm moving these slides, and these slides are moving in RAM memory. So it has some memory because it can go back to the previous slide and then the forward slide. And if I head back, it goes back to the previous slide. And if I hit forward, it goes to the forward slide. So that's the memory. However, if I just shut off my computer now, my notes that I'm taking, they're not going to be saved because these notes that I'm writing here, they are in RAM. It's temporary storage and they're not being saved, but they're still in the memory right now to make it the notes work. That's it for this one, and I'll see you next time.